Hello, I am going to bring you the last part of increasing decreasing functions and the first derivative test. These are just a little more difficult problems. I believe this is the last time I'm going to do it with the different parts. The next lesson, 4.4, based on your guys' recommendations, I'm just going to do all 4.4 together. Tell you can do it over like a week or so and let you guys go whatever pace you want. All right? I think it'll be a little bit easier that way. I'll tell you where the breaks are, where I would break, but you guys can do what you want. So let's start with this one, problems 21 and 22. Why don't you guys attempt to find the answers? We're doing the same thing we did on the last lesson. All right, so the first thing you guys should find is the derivative. Now, the way to find the derivative, you don't really want to use the quotient rule because there's just a coefficient down there. So you divide each one of the numerators by the bottom number, x to the 5th over 5 minus 5x over 5. You reduce 5x over 5 is just x. So you got 1 over 5, x to the 5th minus x. Now, that is not your derivative yet. That's just rewriting the original equation. Now what you're going to do is you're actually going to derive that. 5 times a 5th, woo, it becomes 1. So you got x to the 4th minus 1 equals 0. Solve for x. Add 1 to both sides. What to the 4th power equals 1, but positive or negative 1. All right? These are both my critical numbers. If I wanted to find the critical points, I would just plug them into the equation. You don't even have to do that for these, though. We're going to use them to find our interval. So as with always, you start at negative infinity, go to the lower number, which is negative 1, negative 1 to the positive 1, and positive 1 to number we always end with, which is infinity, open interval. So pick a test number, negative 2, it's just a little bit less. Type it in here. That should say negative 2 to the 4th power. Minus 1 is 15, because negative 2 to the 4th is 16 minus 1 is 15. Little mistake there. Next one, so that's a positive number, which is increasing. So the graph starts by going up. Between these two numbers, 0 to the 4th, 0 minus 1 is negative 1. That is a negative number, and negative numbers are decreasing. All right, then you got right here, pick a number like 2 to the 4th power. 16 minus 1 is also 15. 15 is a positive number, which is increasing. So your graph goes up, down, and up. All right, 22 should already be done. Derive it. 4x cubed minus 32 equals 0. Add 32 to both sides. Divide by 4. X cubed equals 8. Now, because it's a odd exponent, you're only going to have one answer. What number times itself? 3 times is 8, and that would be 2. All right, so you only have one critical number, from negative infinity to 2, and from 2 to infinity. Let's pick 0. All right, 0, plug it into the derivative, not the original equation. You get negative 32, which is a negative number, which is decreasing. All right, 3, 76, which is a positive number, which is increasing. All right, that's it. All right, let's look at problem number 23. This one's a little more difficult. Notice you get a whole big box to fill this in on. All right, so when you derive this, you get 1/3 x to the negative 2/3. You want to rewrite this because you're going to set it equal to 0 and equal to undefined for your critical number. So first off, when I set it equal to 0, never equals 0 because you can never get the 1 to equal 0. Since the numerator can never equal 0, you never equal 0. So f prime x never equals 0, but it can be undefined. So when it's undefined, you want this equation to be undefined. So when something's undefined, what is equal to 0? But the denominator. So you set the denominator equal to 0, divide 0 by 3, okay? Cube 0, 0 cubed is 0, and take the square root of 0, which is 0. Obviously, you can do that in your head if you want, but your answer is 0. So that is going to be your critical number. Now that means you're going from negative infinity to 0 and from 0 to infinity. Let's pick negative 1. It's between these two, right? Type it into the equation. You can type it into this or into this one. I think this is just easier for me. Negative 1 squared is 1. Cubed root of 1 is 1. Answer is 1/3. 1/3 is a positive number. Positive numbers increase. Pick a number 1 here. 1, 3 times 1, it's also 1/3. 1/3 is also positive, which is increasing. So what happens in this graph pretty much is your graph is going to go up. There's going to be an asymptote here at, no, there's no, it just goes up, and it goes up some more. So this is more like a level off, not a critical number. So you don't always have a critical number. All right, derive it. Go. Derive set equals 0. Now this should be a hint of lots of stuff going on. Problem number 24. What we're going to use here is the chain rule. All right, so the way you use the chain rule, you take the inside there, which is x squared plus 2. Your outside is your raised to the 2/3 power. Derivative of x squared plus 2 is 1 plus 0, which is 1. 2/3, u to the 2/3 minus 1 is a negative 1/3. U prime times f prime u. 1 times anything is itself. And then you plug your u back into the u. So 2/3 x plus 2 to the negative 1/3. Now you're going to set that equal to 0 and also undefined. First thing you want to do is rewrite this. So since this is a negative exponent, it is going in the denominator. Since it's the 1/3 power, it is going to be the cubed root. Okay, if this was the 1/2 power, this would be a square root. If this is the 1/4 power, negative obviously, this would be a 4th root. So in order to set this, you set this equal to 0 first. So you're going to take the denominator, which is 2, all right, and you set that equal to 0, because when I multiply both sides by the denominator, it becomes 0 equals 2, which never happens, and 0 never equals 2. There is no critical number based on the answer being 0, the derivative. So now you're going to set this equal to undefined, and then when you set it up equal to undefined, you get the denominator equaling 0. Divide by 3. Cube both sides, 0 to the 3rd power is 0. And then you subtract 2. So you end up actually getting your critical number to be negative 2. So now when we go do our intervals from, once again, negative infinity to negative 2, and from negative 2 to, you got it, infinity. Pick a number between these two. Something like negative 3 is pretty good. Plug it into this equation to, if I type 10 in there, I get a negative 2/3. Negative 2/3 is obviously a negative number, which means it is decreasing. Put negative. We'll go with negative. All right, this right here, you type in 6, you get a positive 1/3, which is a positive number, and positive numbers right here happen to be increasing. All right, so the graph is going to go down and then back up. All right, feel good? Perfect. Now I want you guys to attempt problem 25. Good. Are you done with 25? Hopefully you are, because you used the quotient rule. Numerator x squared, denominator x squared minus 2. Guess what? Both primes are the same, 2x and 2x. Cross, multiply, or use your equation, f prime g, 2x times x squared minus 9, g prime f, 2x times x squared. Now, over g squared, 2x cubed minus 18x minus 2x cubed. 2x cubed minus 2x cubed is 0. You have a negative 18x over x squared minus 9 quantity squared. Now you're going to have to set this equal to 0 and undefined. So when it's equal to 0, you set the numerator equal to 0. Negative 18x equals 0. Divide by 18 and x equals 0. Set the denominator equal to 0. X squared minus 9 equals 0. Square root of that. Add 9 and square root. And you get a plus or minus 3. 0. Negative 3, positive 3 are your 3 critical numbers. So you go in order. Negative 3, 0, positive 3, negative infinity, negative 3, negative 3 to 0, and 0 to 3, and 3 to infinity. 1, 2, 3, 4. You got 4 intervals here. Find a test value. So first thing we're going to do is negative 4. You plug it into this equation right here. Negative 18 times negative 4 times negative 4 squared minus 9 is a positive 1.5. Positive numbers increase in negative 1. Type it in, blah, blah, blah. Calculator should spit out a positive 0.3 as an answer. That's positive, which is also increasing. If you type in a number here like 1, all right, look at negative 18 over positive number, negative. All right, you don't even have to do the math if you don't want, but you can. Negative numbers are decreasing. Type a number such as 4 in here, negative over a positive. Obviously, the answer is negative, which is decreasing. So the reason you're going increasing, increasing, decreasing, decreasing is because at negative 3 and at 3, you have two asymptotes, okay? So what happens here is the graph is going up, and then between the two graphs, your graph is going to make like an upside down parabola, and then after the graph, your graph is just going to continue to go down. And we're going to get into graphing next time. All right, we all good? Try problem number 26. All right, hopefully you're done. Should divide both of these by x squared, x over x squared, 4 minus x squared. If you want to use the quotient rule again, x minus 1 plus 4 times x minus 2. So derive this, you get negative x, negative 1 minus 1 is negative 2, negative 8, x to the negative 3. All right. Now, rewrite that because you're going to have to set it equal to 0 and undefined. Now, when you set this equal to 0, 1 over x squared minus 8 over x cubed equals 0. So the easiest way to do this is add 8 over x cubed, both sides. Now, multiply both sides by x cubed. All right, and multiply every time by x squared. All we did here is cross multiply. 1 times x cubed times 8. Divide both sides by x squared. You get negative x equals 8 and x equals negative 8. If you want to check your answers, you can plug them in and you'd actually get 0. Now, when are they undefined? When either one of these guys equals 0. So when x equals 0, because they both equal 0. So you have two critical numbers, 0, negative 8, negative infinity to negative 8, 0 to negative 8. Oop, that went backwards. No, sorry, negative 8 to 0, and 0 to negative 8. All right, now picking the negative 4 between these two numbers. All right, negative 9, sorry, how I said negative 4. 0.01, which is negative, which is decreasing. Negative 1 between these two. You get 7, which is a positive number, which is increasing. And then if you pick something like 1 between these two, you get a negative number, which is decreasing. All right, are we good? Awesome. I got to clean up these slides a little bit. All right, last question. Got it? All right. This one you have to use the quotient rule for. X squared minus 2x plus 1. X plus 1. 2x minus 2. 1. Got it? 2x minus 2 times x squared plus 1 minus 1 times all that. 2x cubed plus 2x minus 2x minus 2 minus x squared plus 2x minus 1. All right, we're going to combine some like terms here. 2x squared is owned by itself. 2x minus 2x is 0, plus 2x is 2x. Negative 2 minus 1 is negative 3. X plus 1 squared stays x plus 1 squared. And that is your derivative. So what we're going to do is we're going to finish this up very simply by setting the numerator and denominator both equal to 0. When this equals 0, the numerator equals 0. Factor that. Factors of 3, negative 3 that add up to 2. 3 minus 1. X plus 3, x minus 1. X plus 3 equals 0. X is negative 3. X minus 1 equals 0 and x is 1. When we set this equal to undefined, when does the denominator equal 0? So when x plus 1 equals 0, subtract 1 from both sides and x equals negative 1. Notice 1, 2, 3 critical numbers. The smallest one is negative 3, negative 1, 1. Negative infinity, negative 3, negative 3, negative 1, negative 1 and 1, and 1 in infinity. Test value, negative 4. Positive, increasing. Test value here, negative 2. Negative and decreasing. Test value here, 0. Negative and decreasing once again. Ooh, interesting. Because you got a negative 3 over 1. All right, 2.6. Positive and increasing. So it goes up and down. All right, negative 1 is actually an asymptote. And then it goes down and up. All right, and that is your graphs. And that's the end of this. And then we'll continue on with increasing functions